we learned what a plane was in a previous lesson. Remember, a plane is a flat surface that goes on forever in infinite directions. And so we're going to be talking about plane figures. And a plane figure is a figure that lies in a plane. Since a plane is two-dimensional, remember two-dimensional means it has two dimensions. In this case, we're going to have like a length and a width. That's two-dimensional. And so therefore plane figures are also going to be two-dimensional. So let me draw you a plane. Now remember, this is just part of a plane. Pretend that this plane goes on forever, infinitely in every direction, I should say. So what a plane figure is basically if I just cut out a piece of this plane. For example, if I cut out this part right here, and then I also cut out this part right there, and then I also cut out that part right there, then what we make is we're going to make that little triangle on the inside. And that triangle by itself is called a plane figure. It's two-dimensional. It is a flat surface, and they would have, in this case, triangles. We measure them with like their base and their heights. So a polygon is a closed plane figure formed by three or more segments. Okay? And if you look at the polygon that I drew, I have four segments there. Each one of these pieces being a segment, but it can be three, like a triangle, or it can be more. Okay? Each segment is called a side. So in our case right here we have four sides, and oops, I messed up right there, four sides, and each endpoint, these endpoints are called, each one is called a vertex, but all of them together, the plural is called vertices. When we name polygons, you're going to have to look at the vertices. Okay, for example, if I name these here, vertex A, vertex B, vertex C, and vertex D, then I can call this polygon A, B, C, D. Okay? As you're naming these, make sure that you must name the polygon by its vertices in rotational order. Okay? It doesn't matter which one you start off with. For example, I'll give you another example. I can call this polygon, and let's say I start off at C. Okay? I can either go this direction or I can go that direction. I can call it like C, B, and then A, and then D. So I'm going C, B, A, and then going towards D. What you cannot do, and this is wrong, okay, is you cannot call it polygon. And let's say I start at C, I cannot skip around. I cannot go C to A to, let's say, to D to B. I can't just go like that. I have to go in order either this way, clockwise, or sorry, counterclockwise, or I can go this way also, which would be clockwise. Also, we're not really going to call them polygons. Okay, each polygon is going to have a specific name, and so we'll learn the names later on. But don't ever call it like polygon A B C D. They're going to have specific names like triangle A B C D or pentagon A B C D E, okay, or heptagon or octagon. All that stuff are polygons. Okay, concave polygons are it's a polygon that caves in. Okay, so when we see caves, think about it like a cave in a mountain. Okay? If here was like the Franklin Mountains or whatever mountains you want to do, a cave will actually go inside like that, and as the hikers are going up, you can go into the cave, so it caves in. Okay, and if you see here, the easy way is you can kind of see that it goes inward here, so you can automatically tell if it caves in, it's concave, because you can kind of see that it goes inside the shape. Okay, but here's a hint. Okay? If you're not too sure, what you could do is you can extend the sides infinitely into lines. Okay? And the concave polygon, those lines will go inside the polygon. Let me give you an example. Okay? For example, what I'm going to do is I want to extend one of the sides. Notice that the top side, I extended it to the left and to the right infinitely. And then I'm going to do is the left side as well, it goes up and down forever. And then if I do this for all the sides, if you notice when I do this bottom side here, notice how it goes into the shape. The line is going into the shape. If the line never goes into the shape, we call that a concave polygon. And I also, if you do the next line, you can see that it goes inside here as well. And if I do this last remaining line, that one, the line doesn't go in. But if it goes in just one time, it automatically becomes a concave polygon. But you can always tell if it's concave because it kind of goes outward like that and then it kind of goes inward. So once you see that goes inside, that's a concave polygon. A convex polygon is a polygon that does not cave in. Okay? Notice that there is no cave that goes into this polygon on the right. Okay? And same thing, we can do a test. If you extend the sides infinitely, a convex polygon, the lines will not go on the inside of the polygon. Okay? For example, I'm going to show other lines here. If I extend the top side, the red line doesn't go inside. If I extend that side, it does not go inside. That one 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 does not go inside. Okay, and that's the convex test. If the line goes inside, once again, it's going to be concave. It says tell whether the figure is a polygon. If it is a polygon, tell whether it is concave or convex. Okay, so like for example, number one, remember a polygon has to have segments, and these are all segments. Segments are straight lines, or pieces of lines, I should say. So far, it's a polygon, and it is closed. It's not open like this. If it isn't closed, then it's not really a polygon. Okay, but this one is a polygon. And you notice that inside here it goes caves in, or if I extend this line to the right, it does not go in, but if I go to the left, it goes in automatically. That makes it concave. For letter B, this is not a polygon because this top part is curved, and that's not a segment, and a polygon has to have all segments, okay? So this is not a polygon. On C, this is not a polygon. Because of this line here, it's supposed to be like a closed figure, but these are two closed figures, and so you can actually call it two polygons, polygon 1 on top and polygon 2 on the bottom, but the whole piece is not a polygon. And the last one, notice that it is a closed figure, and all the lines are straight, so it is a polygon, so yes, two polygon. And is it a concave or convex? Well, if I extend all the lines this way, none of these lines will go inside. That's the convex test, and therefore all these lines make it a convex. Okay, this shape does not concave. Okay, it doesn't cave in. Okay, it's not. So be careful with that. All right. So now here are some names for polygons with a specific number of sides. You should be familiar with at least most of these. But if a polygon has 3 sides, we call it a triangle. If a polygon has 4 sides, we call it a quadrilateral. If a polygon has 5 sides, we call it a pentagon. If a polygon has 6 sides, we call it a hexagon, and so on. I'm just going to put them here. Heptagon, octagon is the one that everybody knows. Nonagon is a 9-sided. Decagon means 10 sides. 12 sides is a dodecagon. And if it has more than 12 or even 11, okay, if it has 14 or 20 sides, we can call it an n-gon. An n is the number of sides. Okay, for example, if you have 52 sides, then we can call it a 52-gon. An equilateral polygon is a polygon with all congruent sides, and you can remember this because equi means like equal, and then lateral, like lados, lateral means sides, okay? So on the picture on the right, for example, we have that diamond. If all sides are equal, then we can call this an equilateral polygon. An equiangular polygon, okay, and if you kind of use some thinking like the last one, equi means equal, and angular means angle. So it's a polygon with all congruent angles. And so if you look at that, the quadrilateral on the right, the 4-sided quadrilateral, if all 4 angles are equal, that makes this equiangular polygon. And regular polygon is a polygon with all congruent sides and all congruent angles. Okay? So all the sides have to be equal. And so that means if all the sides are equal, then the polygon is going to be equilateral. And if all the angles are congruent, then it's going to be also equiangular. So if it's equilateral and equiangular, then we call that a regular polygon. So name a polygon according to the number of sides. Tell whether it's equilateral, equiangular, or regular. Okay. So if you look at this one here, it has 4 sides, and you might be tempted to call this a rectangle. But for now, we haven't really gone over a rectangle, so we're just going to call this a quadrilateral. If it just has 4 sides in general, it's considered to be a quadrilateral. So like squares, rhombuses, trapezoids, rectangles, those are all quadrilaterals. Okay? We'll get into more detail on those later, but for now, just call them quadrilaterals. And this quadrilateral, you notice that all the angles are right angles, and so therefore they're all congruent, and so it is equiangular. But it is not equilateral because this side is not equal to that side. So all sides are not equal, so it's not equilateral. So it's just an equiangular quadrilateral. For B, if you count the number of sides, it has 1, 2, 3, 4, 5, 6, 7, 8. So this is like a stop sign. This is an octagon. And because all sides are equal, it will be an equilateral. Okay. But at the same time, because all these angles are equal, then it's also equiangular. And when it's equilateral and equiangular, we call those regular polygons. In this case, we call this like an octagon, and it's also regular, so it's a regular octagon. For C, if you look at it, has 3 sides, so it's called a triangle. But if you notice, the sides are not equal, and the angles are not equal. So it's just a triangle. It's not equilateral, it's not equiangular, and therefore it's not regular. It's just a triangle. For example 3, it says the triangle on the right is a regular triangle. Find the value of x. Okay? So I had been talking about this throughout class, and I said, okay, look at these 2 angles. Okay? What do I know about them? What's the relationship between these 2 angles? Well, because it's regular, that means all sides and all angles are equal. So that means that this angle is equal to this angle, and it's also equal to that angle. But the relationship between this one and that one is they're both equal. So I can say 2x equals 2x plus 30. And then if I do my algebra, subtract the x to get rid of the x and bring it to the left side, then 2x minus x is equals to x, or 1x. You don't have to put the 1. Bring down the 30, and you get that x equals to 30. So that's the answer for letter A. For letter B, it says what is the measure of each angle? Once again, if x is 30, then I can substitute, and I can plug in 30 there, and to get 2 times 30, and 2 times 30 is 60, and I can also plug in 30 here, and 30 plus 30 is going to give me 60, and so therefore these 2 are 60. Okay. And then also because it's equilateral, then we can also say the angle over here is 60, so basically every angle is 60 degrees.